Okay, in this video, we're going to learn two new derivative rules, the derivatives of natural log and of e. So let's look at e first. If we have e to some expression up here that has a variable in it, that's all this f of x represents, e to something with a variable in it, and we want to take the derivative, we get e to the power of f of x, notice these are the same, times the derivative of f of x, which is the derivative of the power. So if you want to memorize this in words, the way I think of it is everything stays the same because these two are the same. So everything stays the same times the derivative of the power. That's all you have to do. Keep everything the same and then multiply by the derivative of the power. So let's look at a couple simple examples. We have y equals e to the power of 2x. So my derivative would simply be everything stays the same times the derivative of the power, and the derivative of 2x is 2. That's my derivative. Now, I like to write this with the numbers in front. So 2e to the 2x. It's a little bit cleaner. I don't have the dot, but that's up to you. Again, over here, I have f of x equals e to the negative x squared. So the derivative would be everything stays the same times the derivative of the power. And the derivative of negative x squared is negative 2x. And then again, personally, I like to write the negative 2x in front, followed by the e to the negative x squared. Okay, and that's fine. That's your derivative. You do know that we could write this if we wanted to by bringing the e to the power of x squared to the bottom and making it a positive. But this is fine. This is okay also. Okay, I want you to take a minute, and I just want you to try this one, and then check your answer with me. Okay, on this one, we're going to take the derivative, and again, everything that you see there is going to stay the same. And then times the derivative of the power. Well, this is my power, and the derivative of that is going to be 4x plus 1. And since that has more than one term in it, there's a plus in the middle, I need to put that in parentheses. So that's my derivative. Now, again, it's a personal preference. I like to write the 3 in front. I then like to write my 4x plus 1, my binomial here, and then e to the power of 2x squared plus x. And I do not need to multiply this 3 through. In fact, this is really factored form if I was going to use it to solve something. So I'm just going to leave the 3 where it is. Okay? All right, take another minute, try this problem, and then check your answer with me. Okay, so the derivative of this is going to be everything stays the same times the derivative of the power. The derivative of the power is just negative 3. Okay, now, since this is just one term, it's a negative 3, I can multiply that by the negative 4. So I can get 12e to the power of 2 minus 3x. And that would be my derivative. Okay, let's look at using this for just a second. So find, and they're telling me in terms of e, so we don't need a calculator, the gradients of the tangents, so the slope of the tangents to the following curves for the given values of x. So again, here's y equals e to the 3 minus 4x. I need a derivative anytime I'm talking about slope of tangent. Everything stays the same times the derivative of the power, which is negative 4. You're going to hear me say that a lot. And then I'll write the negative 4 in front and everything else the same. So this is my derivative. I want to find the value of the slope of the tangent at x equals 2. So I'm just going to take that and I'm going to plug in 2 and simplify that. 3, this is going to be 3 minus 8, which is going to be negative 5. And that's my answer. You could also write it as negative 4 over e to the 5th. Either one is correct. Okay? All right, take a minute and try this next problem. Okay, so first, I need a derivative. So everything stays the same. Times the derivative of the power, which is just negative 1. So I can simplify that to negative 3e to the negative x. Pretty easy, right? Now I just want to plug in my x is negative 2. So negative 3e to the negative 2 simplifies to negative 3e squared. And that's in terms of e, because we don't need to use a calculator for it. That's my answer. That's the slope of the tangent at negative 2. Okay? All right, now let's look at our natural log rules. So again, if y equals natural log of f of x, so this is just something inside my natural log that has a variable in it, and I want to take the derivative, then I have the derivative of f of x over f of x. Notice something here, your natural log has disappeared. So when you take the derivative of natural log, you're no longer going to have a natural log in your problem, in that part of your problem, okay? We're going to look at combining the rules in a second. So how would we write this in words? Basically, I want to take the derivative of the inside. So the derivative of the inside of natural log divided by, or over. So the derivative of the inside over the inside. Notice this part is not the derivative. So this is like as is, the inside as it started with, okay? Okay, looking at this one, you need to be careful because of this 2 right here. So if you know your rules of logarithms, you could move this 2 up as a power here. And then when you did it, you'd be dealing with chain rule. Or you can understand that this is just 2 times all of this. And so when I take the derivative, I can look at it as 2 times the derivative of all of that. And so the derivative of natural log is going to be the derivative of the inside. So the derivative of 3x plus 7 is 3 over the inside the way you see it. And then, of course, I can simplify that. 2 times 3 is 6 over 3x plus 7. And that's your derivative. That's all there is to it, okay? So on this one, I want to take the derivative. And again, there's nothing out front, so I don't have to worry about that. But the derivative of the inside, which happens to, again, be 3, that's the derivative of this part, over the inside. And that's my derivative. Okay, let's look at some other examples. I want you to take a minute, and I want you to try this first problem right here, and then check your work with me. Okay, taking the derivative of this, dy dx, is going to be the derivative of the inside, which is going to be 3x squared, over the inside, which is x cubed. And we know we can simplify this, so we would do that. We would simplify this to 3 over x, and that's my derivative. Okay, you're going to do this one, but I will get you started on it. Anytime we have something in here that doesn't look so pleasant, we need to write it in a form that we can easily take the derivative of. So I would rewrite this inside as x plus x to the negative 1. Okay, so now take a minute and try this problem and then check it with me. Okay, here we go. Derivative is equal to the derivative of the inside. The derivative of x is 1. The derivative of x to the negative 1 is negative x to the negative 2 over the inside. Now, that is my derivative. Now, that's not really pretty, and that might be a little bit hard to work with if I wanted to do algebra with it. So let's see what we can do with it. I can start by rewriting it. 1 minus, this would be 1 over x squared. And then x plus 1 over x. And so that's a little bit better, but it has fractions and fractions, and that's kind of ugly. So what I could do is I could multiply by something that is going to clear the fraction on the top and the fraction on the bottom. So I'm allowed to multiply by something equivalent to 1, and I would take this x squared over x squared, because watch what happens here. X squared times 1 is x squared. X squared times 1 over x squared is just going to give me a negative 1. X squared times x is going to be x cubed, and then x squared times 1 over x is going to give me plus x. And of course, that's not the only way to do it. You could have found common denominators on the top and so on, but that is a quick and easy way to do it. Okay, let's look at this using this information to, using our derivatives to find other information. This says find the minimum value of the function. We know that minimum means I still need a derivative first. So the derivative is going to be, this part is separate. These are 2 separate terms. So the derivative of 2x is just 2 minus the derivative of natural log is the derivative of the inside, which is 1 over the inside. So that's really my derivative right there. And then if you recall from last year, to find a minimum value, we set the derivative equal to 0, and we solve for x. And so in this case, I'm going to move my 1 over x over here. I'm going to multiply both sides by x. I'm going to get 1 equals 2x, and then I'm going to divide by 2. So in this case, I only got one x value. So if everything was done right, that should definitely be the location of my minimum. But you could check it by doing a sign chart. If I plug in a number to the right of 1/2 into my derivative here, so a number like 1, I'm going to get a positive. And if I plug in a number to the left of 1/2, like 1/4, I'm going to get a negative. Okay, I can't plug in 0 because there's an x on the bottom there. So definitely this is a minimum, because that's what that section of my graph would look like. And so what I know is that this is the location of my minimum. This is the x value of my minimum. It is not the value of the minimum, like how low does it go. The value of the minimum is the y value. So I need to take this x to the 1/2 x. Sorry, I need to take x equals 1/2 and plug it back in. So when I do that, that looks like this. And I get 2 times 1/2 is 1 minus natural log of 1/2. And since we're just working without calculators right now and just checking our derivatives, this is what I would leave. I would say that this is my minimum value. If you had a calculator, you could find the decimal version of that. Okay? Okay, so we do have 3 more problems, and what we're going to do now is we're going to look at putting some rules together. So we just learned natural log and E rules, but we've previously learned quotient and product rules, so we need to be able to put those together. So what you're noticing here is this is a quotient rule, but it has a natural log in it. So if we think about what quotient rule is, we have low d high, so I'm going to need the derivative of the high, minus high d low, so I'm going to need the derivative of the low. And then, of course, over the square of what's below. But maybe we want to find these first. I'm not saying you have to do this, but for some people, it's going to help when we get a lot of rules involved in a problem. So if I think about the derivative of high, that's the derivative of natural log of x. That's going to be the derivative of the inside, which is 1 over the inside. And then the derivative of low, which is just x, is going to be 1. Having this here might help you when you go to take the derivative of the whole thing. So the derivative now is going to be low, just like you see it, d high, which is nice because we already have it, 1 over x, minus high, just like you see it, d low, which is we already have, it's 1, over the square of what's below. I would clean this up a little bit. X times 1 over x is just 1, minus the natural log of x over x squared. And that's my derivative. Okay, let's look at this one. We do need to rewrite it first. We want to rewrite this radical as a power of 1/2. So 5 plus 3x squared to the power of 1/2 times the natural log of x. So hopefully you're seeing here that this is product rule. This is one term and this is one term. So basically on product rule, we're going to need the derivative of each one of these separately. So you might want to come over here and take the derivative of this. The derivative of this is going to be 1/2, inside stays the same, subtract a power, times the derivative of the inside, which is going to be 6x because it's 2 times 3. And then you may want to even clean this up a little bit. So you may want to clean this up, and this 1/2 times 6 is going to be 3x. And then I have all of this left. Okay, so that's the derivative of this. And then you may just want to come down here and take the derivative of natural log of x. So when I take the derivative of natural log of x, I get the derivative of the inside, which is 1 over x. And now you already have these derivatives taken. So when you go to do product rule and take the derivative of this, you're going to say first, just like you see it, only I'm probably going to write it with parentheses. First times the derivative of the second, which is natural log, which we already have the derivative of, which is going to be 1 over x, plus the second, just like you see it, times the derivative of the first, which is all of this stuff. So it's kind of nice that we already found that. So this is my derivative. Now, I probably wouldn't do a whole lot to this, but if I needed to work with it, I would take out a greatest common factor. And we talked about this on the last lesson. If I take out a greatest common factor, I'm taking out the one that has my smallest power. And then what's going to be left is, if you think about 1/2 minus negative 1/2, we would have 5 plus 3x squared to the first times 1 over x plus, and then I took this one out, so I'm really going to have 3x natural log of x, and I just wrote that in a different order. And there's a lot more you could do with this, but for our purposes, this would probably be sufficient for solving, or we could deal with what we needed to do with this later. Okay, so that's your derivative. Okay, let's look at one more. Notice this is also product rule, so I have this times this. So again, it's up to you, but you might want to come over here and you might want to ask yourself, what is the derivative of 4x? Well, that's 4. And then what is the derivative of e to the 2x? And that's going to be everything stays the same times the derivative of the power, which I would write like this. And now you already have these derivatives done. You don't have to worry about it while you're already taking the derivative of this using product rule. So these are already done for you. So the derivative of this is going to be first times the derivative of the second. Make sure you're using the right derivative. That's this one down here, which is going to be 2e to the 2x, plus the second times the derivative of the first, which we found to be 4. I can do a little bit of math with this. I'm going to do 4 times 2 is 8x e to the 2x. And then I'm going to rewrite this as 4 e to the 2x. Now this is fine, and this is good if all you're asked for is the derivative, but if you're going to do math with this, solve for a stationary point or something, you're probably going to want to take out a greatest common factor, especially the e to the 2x, but in this case we can also take out a 4. So 4e to the 2x is my greatest common factor. That leaves me with 2x plus 1, and that's my derivative. Okay? All right, go back and review anything in this video that you need to, and I will see you in class.